Hi everyone, in today's video we will talk about the Tf-Idf, another method to generate vectors from words. We will cover the theory in this video. In the next video we will have an implementation in Python of the Tf-Idf method. Here we have a brief introduction, the formula, how to calculate Tf-Idf, the word importance and how is that important in Tf-Idf, and a brief framework. We will go over an example. We have some applications and also the references. So if you need more information about TF-IDF, check our references and the web references in web courses. TF stands for term frequency and IDF stands for inverse document frequency. So we have the TF-IDF, that is the term frequency inverse document frequency. It's based on bag of words and use the frequency of the words as a basis. So as we said, we're going to have the term frequency. That's the same thing of saying that that part is the bag of words. It's where we get the word frequency, and it's the exactly same thing the bag of words does. So the TF part we already know. And the IDF, it's the inverse document frequency, and we're going to check that a little bit later. It creates a document term matrix where the columns, we have one column per document, and we have one row per word in the document. So we have here an example, and we can see that we have 4 terms or 4 words, and we have 2 documents. So our term vector will have only 2 dimensions because we have 2 documents, and our document vector will have 4 dimensions because we have 4 terms. This one, maybe it's just considering the frequency of the vector, so that's why we still have to input the weights, that is the IDF. We're going to see it later. So the TF-IDF will generate a weighting factor for each word or document pair. How important is a word in the context of the corpus? And that's what TF-IDF does. It not only checks the frequency of the word, but also gives a number, a weight number that says what is the importance of that word for that document. And the goal is to generate vectors of words. Again, our end goal is to have a representation of a word in a numerical form. It generates sparse vectors. The same way as bag of words, we have sparse vectors for TF-IDF because we are based our vector in the term frequency. So the number of non-zero values in the vector is equal to the number of unique words in the document. And that is good and bad. There are some controversial thinking about sparse vectors because some of the people think that this optimizes memory and others think that it's a little bit large. The vectors are very large and they can actually not improve your memory. But well, that's what we have for TF-IDF. And here we have another example that let's say that we have 2 sets of surgeries, like names of surgeries, and we use bag of words, and later we're going to do a TF-IDF that we have the weight vectors in the end. So the set 1 for each term that we have in the set of surgeries, we will have 1 vector. And the same thing for the sets. Every set will be considered a document, and every term inside the set of surgeries will be a word. Here we have the formula. TF-IDF, it's basically TF multiplied by IDF. So the first term is the TF, and we are basically calculating the frequency of the word. We have here TF of a TD is the number of times that the term T appears in the document D, divided by the total number of terms in the document D. So we just want to see the frequency of that word in that specific document. Let's remember that the TF-IDF is specific for each pair of word and document. And then we calculate the IDF. The IDF is the log of the total number of documents in the corpus divided by the total number of documents with the term T in it. So what we want to see here is from all the documents, which ones are the ones that have the word T on it. So let's say that we have 100 comments, and from those comments, we only have the word car on 3 of them. So we're going to calculate the IDF as the log of 100 divided by 3. And the TF-IDF, we're going to multiply TF by IDF, and we're going to get the weight that represents the statistical measure used to evaluate how important a word is to a document in a collection or a corpus. So here's a question. Which words should receive higher weights? The common words or the rare words? The rare words. Why is that? Because common words like as and the, if will rank low because they appear a bunch of times. So if we remember the formula in the IDF part, we're going to have the total number of comments divided by the total number of comments that that word appears. And if we know that that word appears a lot of times, we will have a log very small. So that's why it will rank low. We're going to have a very small number that will approach 0 if the word is very common. And for the rare words, we will have the inverse, because if it's relevant to the document, we're going to have a log that will be a little bit higher, just because we will have the, let's say, 100 comments, and it will only appear, instead of in 98 as a common word would be, it will only appear in 3 of them. So we will have a value that it's higher and will approach to 1. And an example would be a word like politics that appear many times in one document, but not in all of the documents. So we know that this word is relevant for this specific document, and it's a rare word, does not appear in all other documents. So we will rank this word high. Here is a basic framework. Remember, this part, it's only specific for the TF-IDF, but we have to recap and look back to the word embedding framework if you want to see the whole picture. Okay, here we have the inputs that will be the documents, in our case, the comments. We're going to do a simple or extensive text processing. And from the text processing, we are able to calculate the term frequency, the TF, and the document frequency, IDF. And then we multiply them to get the weights. And with those weights, we're going to apply to the vectors that we had before in our bag of words, for example, because we're going to apply this to the frequency of the words. And we're going to generate the word vectors and the document vectors. It is important to remember that after that, if we need to compute anything else, and we can use machine learning algorithms to find important information, and all the applications we're going to see in this slides, they use a machine learning algorithm with TF-IDF. Let's go over an example so that can be a little bit more clear for you. We have here 2 documents. Document A is create a different word, a new word. And document B, it's example of a word indeed. So we have here all the terms, create a different word, new example of indeed. And we have both documents, A and B. And the first part, it's just the count of the words. And that, remember us, that's bag of words. So we have here all the counts for documents A and B and all the terms. We will calculate the TF, that is the term frequency. So we know that we have in document A 7 terms. So the term create appear 1 time in the document A. So the term frequency will be 1 divided by 7. And for the document B, that will be 0 because the word create does not appear at all. And then we will calculate the IDF. That's the log of the total number of documents that we have, that's 2, and how many documents that word appear on it. So create only appear in document A, so we have the log 2 divided by 1. Let's, in this case, we have the exactly same because most of them only appear in one of the documents or on both of documents. So we can see here the log of 2 divided by 2 is 0. So the term frequency of the TF-IDF of this word, for example, A, will be 0. So we know that A, it's not a very important word because it appears in both documents. And that's one part that it's important to see, that common words that appear every time, they are not important to the whole context of the corpus. So here we can see also in the end, we have the document vector and the word vector. The word create vector has 2 dimensions because we only have 2 documents. And the document A vector have 5 dimensions because we have 5 different words. And if you can see, we're gonna have a sparse vector that contains a lot of zeros. So that is common, it's the same thing that we had for a bag of words. TF-IDF is more commonly used than bag of words, and that's because it gives a meaning to the word more than just the count. It gives a weight, so we can compare words for their meaning in the whole corpus or in a specific document. And many applications use TF-IDF. The first block here, we can see that a survey conducted in 2015 showed that 83% of text-based recommender systems in digital libraries use TF-IDF. That's a lot. 83% of recommender systems that are based in text use TF-IDF as their vectorizer word embedding technique. That's very important. Like we can say that Netflix probably used TF-IDF and Google as well. So we can see the second block, variations of the TF-IDF weighting scheme are often used by search engines as a central tool in scoring and ranking a document's relevance given a user query. That's from Wikipedia. So we know that the ranking algorithm without the words will rank the most important things first. So when they are using this rank algorithm is using words, they need TF-IDF in the middle so they can transform words into vectors and make calculations with it. Automatic web tagging, and that's the example that we have here. It's another application because it says like repair appears 26 times, customer 85 times, and then it gives a weight to those words. And that way we can see which word appears more and in the whole corpus, not only in one document. And it's also used for information retrieval. And can you imagine, like, let's say that we are looking for LeBron, and the results will be displayed in order of relevance, right? So the words that are more important linked to LeBron will appear first. For example, sports articles and that kind of a subject is related to the word that we are looking for, and because of that the TF-IDF will give that word LeBron a higher score, and all the other words that are higher score as well will be in the higher rank. Also, keyword extraction. The TF-IDF is also useful for that because extracting keywords from text, it's exactly what TF-IDF is doing. The highest scoring words of a document are the most relevant ones to that document, and therefore they can be considered the keywords for that document. That is pretty straightforward, and We can see that in many applications. Here we have some references. Feel free to check them if you need more information about TF-IDF. Also, stay tuned for the next video because we will go over implementation in Python of TF-IDF. See you next time. Bye-bye.